Hi everyone, welcome to Math 5610 Analysis 1. I'm Dr. Quinn Morris and I'll be your instructor for this course for the entire semester. The first question you may have is, well, what is real analysis? Real analysis is the study of real numbers, of sequences of real numbers, and of real valued functions, that being functions whose outputs are real numbers. For our purposes, we've selected topics for this course which are important as background knowledge to be an effective instructor of Calculus 1 or 2. So while real analysis spans an incredibly vast amount of the literature, we're really only going to look at topics that are really foundational to understanding Calculus 1 and 2 and are foundational to understanding and addressing students' misconceptions about Calculus 1 or 2. Occasionally, we may take some diversions to topics in real analysis that I find particularly interesting just from a purely mathematical perspective. And even though these are topics which are selected because of their importance in teaching mathematics, that doesn't make them any less interesting mathematically in their own right. So we'll be doing a lot of very interesting mathematics. It's just that the exact content has been selected for this particular purpose. So in this course, you might be wondering what you're going to do. Primarily, you'll be watching recorded lecture videos like this one and completing activities to help you learn the content of the course. Once you've done that, you'll have the chance to complete exercise sets to help strengthen and deepen your knowledge. And finally, you'll have a couple of opportunities during the course to demonstrate mastery of the material through a midterm and a final exam. The dates of the midterm and final exams can be found in the syllabus, which is linked on the course site. Each week, you will have videos posted on Monday, Wednesday, and Friday afternoons. Often these will just be single videos, although occasionally I may break them up into smaller chunks, but videos will be posted on Monday, Wednesday, and Friday afternoons unless otherwise announced. Exercise sets will be posted each Thursday, or nearly each Thursday, and will be due the following Friday. Since this is an online asynchronous course, the only times that things are due are the exercise sets, which again will be due on Fridays, the midterm, and the final exam. When you choose to watch the videos is up to you, and I will not enforce any particular timeline. Some of you may opt to set aside time, say on Monday, Wednesday, and Friday evenings to watch the videos sort of as they come out. That would allow you then the optimal amount of time or the sort of full amount of time to work on the exercise set that will be based on those videos. However, others of you may very reasonably opt to set aside some time on Sunday or the following Monday to just watch all the videos that came out the previous week and then begin working on the exercise sets. However you choose to do it, I would suggest that you make sure you have viewed all the videos for a given week no later than the following Monday. That gives you time to work on the problem set, to perhaps, spend some time bouncing around ideas, try some things which may fail at first, reach out to me if you need help, and still have plenty of time to get the assignment submitted by that Friday. That concludes our overview of the course. And now we're ready to jump into the content. Roughly, the course will be broken up into two chunks. The first piece, which will take about 2 weeks, will be a quick overview of the concepts and theorems that you would have learned in a Calculus 1 or 2 course, and possibly have also seen revisited in an undergraduate real analysis course. We will move through this material quickly. The idea will be to refresh ourselves on some concepts, some methods of calculation, and also to challenge ourselves with some more conceptually difficult problems in order to make sure that we fundamentally understand the results before we move on to the second part of the course. In the second part of the course, we will pass back through all the same material, this time much more slowly, making sure we understand and are able to prove each of the results, understanding cases where the results may not apply, and understanding the most general settings in which we can prove the theorems of calculus. So that concludes this video, and you're now ready to jump into the course material.